Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 3 from lesson 6-4 in the SavvasRealize Algebra 1 textbook. The goal of this video is to use the explicit formula, and I'm going to put a caveat on there for geometric sequences. So just like in my last video, right, I could make a recurring formula for arithmetic sequences as well. So it's important that you have to note that this is for geometric sequences only. Alright, so let's talk about what explicit formula means. So if I'm in English class and I'm doing something explicitly, I don't mean inappropriately, although we do use explicit for that as well. I think about when I was a kid and my brother would go out of his way to be annoying to me. For example, we'd ride in the car and he would purposefully breathe at me. Now, I don't mean like normal breathing, he'd like blow, really. So he was doing that explicitly to upset me. Okay? Or like this kid is eating a watermelon. He's totally eating that rind explicitly to get attention for it, probably, right? Like, he wants people to notice how weird he is eating that watermelon. Okay, so when we do something explicitly, we are doing it purposefully, okay, or with a reason. So now let's take this to math class. In math class, an explicit formula is meant to find a term in a sequence. And so it's not generating an entire sequence like recursion did. It is finding a term somewhere along the path. Okay? Here's why you might want to do it. Say, for example, you're a manufacturer and you want to figure out how much weight something is going to have. And say you want to look at, like, I don't know, say something builds up on weight, right? You have like maybe like a table, right? And that table can only handle so much weight on it before it breaks. So you want to see how many of whatever you're packing on that table you can stack before the table busts. Now, I might explicitly want to figure out the weight of a certain number of these if I know that the table can only hold like 400 pounds or something. Okay, so I'm going to find a number, a term number that I want, in this case the 10th term, for example, but I don't want to have to actually calculate that 10th term. I'm going to explicitly search for it. Explicit formulas are generally the type of formula that we use when we create equations. So like when we start Algebra 1, right, we're like, let's make a line, and you do all these like problems like Linda's walking 3 feet forward and 2 feet up, and you make a formula from that. That's what we're doing. Okay, it's just now it has a different name and a little bit of a weird layout that makes people uncomfortable. Okay, getting off that soapbox. So just a reminder, a sub n just means this term. A sub n minus 1 means the previous term. Alright, a sub n plus 1 means the next term. So those are my little vocabulary boxes as I create this formula. So let's read through the formula in English so that you understand what we're doing. To find this term, you need to take the first term and multiply it times the common ratio raised to the term number before's power. A little weird, but okay. So let's give this a shot. Okay, so the first thing we need to do is identify our a sub 1. That's the first number in the sequence. In this case, my first number is 8, so that is a sub 1. Next thing, I need to find my r, my common ratio. So my common ratio in this situation, I'm going to take just a number and divide it by the number before it. Doesn't matter which set you choose, but it has to be a pair that are adjacent, which means next to. I'm going to reduce that fraction as well. So 12/8 is the same thing as 3/2. And so this thing is asking us to find the 10th term in the sequence. So I could continue multiplying by 3/2 over and over, but my numbers are going to get real ugly. Like real ugly real quickly. Let's put it that way. So let's create our formula, and then we'll figure out a sub 10. All right, so here we go. So a sub n, so to find this term, I need to take the first term, which is a sub 1, and multiply it times my common ratio raised to the n minus 1 power. Okay, and that n minus 1 just chills in there. So explicit formulas don't need you to state what your first term is because that first term is built in there, which is kind of nice. It's nice not having to have two formulas. All right, so now we're going to look for a sub 10. So we are explicitly searching for that 10th term. I don't care about the stuff before it. I don't care about the stuff after it. I just care about that 10th one. So what am I going to do? I'm going to do 8 times 3/2. Now that 10 is my n value, so I'm really raising it to the 10 minus 1. So that 3/2 is to the 9th power. Now remember, when I calculate this on my junky little calculator, what I'm going to do is I'm going to take 3/2, raise it to the 9th power, and then multiply it times 8. Or if you go on to Desmos, just type it in as you see it, which is what I'm going to do here. So I'm doing 8 times 3/2, close that parentheses, and again that was to the 9th power. And so my final answer is 307.54. Now, see how it goes on for forever? That's what's really kind of junky about these little formulas is if you have like a fraction here for your rate, you tend to have to actually eventually round, right? Because those digits are going to get ridiculously long. So eventually Savvas is going to be like, well, round it to the nearest hundredth or something like that, okay? So just be ready for that. Okay. So now on our next part of it, part 2, it says what is the 12th term of the sequence that's described? And they give you an initial condition and they give you a recursive formula. Well, that's annoying. So what I need to do is I need to maybe write out the first couple of terms in my formula so that I can then create an explicit formula from it. Okay? So remember, what this recursive formula says is to find this term, take 6 and multiply it to the previous term. Then they tell you what your a sub 1 is. So this says that you're starting at 3, and to get to the next term, I need to multiply by 6. So 3 times 6 is 18. That didn't get me very far. I don't know what 18 times 6 is. So I get a calculator. 18 times 6 is 108. Okay, it doesn't really matter, yada yada yada, whatever it is. Okay, so this 3 is my a sub 1. And my r, they actually give you the r in the recursive formula. It's right there, it's my 6. So I didn't have to write the sequence down, but I feel so much better writing the sequence down, let's be honest here. So now let's write the explicit formula. And you can either do it from the sequence or do it from the fact that you already know the values here. So a sub n is equal to my a sub 1, my initial condition, which is 3, times my rate, which is 6, to the n minus 1 power. So that'll find any term in the sequence. So if I want to figure out the 500 billionth term, I could do that. I'm lazy, I'm not going to, but I could. Alright, so now, if I'm finding the 12th term, I'm looking for a sub 12. Okay, so I'm going to take 3 and multiply it by 6, which is raised to the 12 minus 1 power. So a sub 12 is equal to 3 times 6 to the 11th. And that's what I'm going to do on Desmos. And that's a really big, really hideous number. So you might be asking yourself, why did that get so big? Why is that so big and so ugly? Well, remember, this is an exponential function, isn't it? When I multiply by something over and over and over, and you can see that it's exponential. You see the exponent, yo. And so remember, those exponential functions, they grow very, very, very quickly. So it seems like this is like a number that doesn't seem reasonable, but it is. All right, it's just that's the way exponents grow. Remember, they graph like this. Anyway, so that is how we use the explicit formula and how we go from a recursive formula to an explicit formula. Until next time.